What we have here is some equipment to enable us to produce a sort of stress-strain curve on a piece of wire coat hanger that's here. We have is a bracket that pulls downward. We're going to measure the downward displacement of that bracket on the x-axis here. And we're also going to measure the force required to produce that downward displacement of this bracket and plot that on the y-axis here. And so again, this is analogous to a stress-strain curve where stress would be on the y-axis and strain would be on the x-axis. And so I'm going to turn this dial and move this bracket downward. And as I move this bracket downward, you can see that I'm increasing the force and also increasing the downward displacement. I'm going to go a little ways here and then stop. And then I'm going to relieve that force. Let that bracket move upward. And you can see that the forward and back trajectory along this strain curve is pretty linear and also pretty much follows the same track. And I'm going up again and down. And what we're seeing here is elastic behavior. That when we release the force on the wire is sort of springing back into its original shape. But let me go further. Okay, let's apply a bit more force. And what we should see is deviation from linearity as we continue to apply more force. And what I especially want to point out, how as I apply more force, that line tends to sort of curve over, and a curve over downward as we go farther and farther. Okay? And so what's happening here is we've gone out of elastic behavior into more plastic behavior where the material will not rebound once I release the force. And let me show you that. I'm going to relieve the force here, and you can see that that downward trajectory, if you will, that return trajectory is not the same as how we got there in the first place. This wire has been permanently deformed out of shape. Again, because we've gone far enough into plastic behavior by applying a lot of force.